A new brain for an old printer. So the control board of my old Prusa MK2 burned out a couple of weeks ago after thousands of hours of printing. Instead of replacing it with 5-year-old hardware, I put the new Duet 3 Mini in it to give it state-of-the-art silent stepper drivers and one of the best web interfaces there is on the market. I'll go over the installation and rewiring process so that you can also follow along if you're interested in trying out RepRap firmware instead of Marlin. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. This video is sponsored by Squarespace. Easily create your own professional website and support the channel at the same time by starting a free trial at squarespace.com/cnckitchen. This was the first Prusa I ever bought almost 5 years back. And that has probably done more than 10,000 hours of printing with hardly any problems during that time. Unfortunately, last fall, the first magic smoke escaped its electronics housing, and that was when the power connector of the heated bed melted. At that point, I was able to replace it with a new one, but only a couple of weeks later, the machine greeted me again with a nasty smell and another bed heating error. After looking at the electronics, I realized that it was even worse than last time, because both power input connectors melted right in their socket. Hence, the terminal blocks were not salvageable anymore. I could have desoldered them, but I thought I'd save myself the hassle and put a new board in it, because I need a reliable machine and not one where every bunch of weeks something breaks. A new Rambo Mini with at least 5-year-old technology, which would have been the easiest option, would have cost me almost 100 euros, so I thought about alternatives. My E3D tool changer is using a Duet 2 mainboard, which I really enjoy using. Unlike most other control boards out in the wild, it's not using Marlin but RepRap firmware, which you primarily find on the Duet boards. The thing I really enjoy about RepRap firmware is that you don't have to compile and flash your own firmware. Everything on the Duet board gets configured via G-codes, which makes changing settings that would on a Marlin-based system require recompiling so accessible. The other thing is the web interface. Basically all new Duet boards either have Ethernet or Wi-Fi connectivity, which is used to access Duet web control that's directly running on the main board. So no additional single board computer, power supply and Wi-Fi dongle are necessary. Compared to Octoprint, it lacks the huge amount of plugins, but is way more stable and quicker to use and even works great on phones from all of my experience. Unfortunately, the recent Duet 3 is 260 euros, which is more than some new printers cost and is way overpowered for what I needed on my Prusa. Fortunately, Duet finally released a spec-down version of it called the Duet 3 Mini 5 Plus. This is the successor to the old Maestro boards and primarily aims towards 3D printers. Even though it's not as powerful as its big brother, it's, in my opinion, a perfect solution for 95% of all printers out there. It features quality components, 5 stepper motor channels, and uses TMC 2209 drivers. It has a fast 32-bit ARM processor and enough I/O, PWM and thermistor channels for most projects. It still costs £99, but its integrated web interface saves you from buying an additionally Raspberry Pi and power supply for running Octoprint. If you are interested in RepRap firmware in general, there also recently popped up a port for STM32 and LPC processors. To try that out, I already got a Mellow Fly board, which looks very much like a cheaper version of a Duet. So make sure to be subscribed and have selected the notification bell to not miss that. Let's continue with my broken Mark 2.5, but you can also use this as a guideline to fit a Duet 3 mini board into most other machines. There is also already a guide for the popular Ender 3 available. Since the Duet 3 mini board is quite a bit bigger than my Rambo Mini, I had to make a new electronics enclosure. Fortunately, there is a Duet version of the Caribou printer, which is a modified version of the Mark III. Since their design is available on GitHub, I loaded the step file into Fusion 360 and modified it in a way that it fits my Duet 3 Mini instead of the Duet 2, and I also had to modify the mounting points so that I can screw it into my aluminum frame instead of the extrusion gantry of the Caribou. I also increased the box thickness because I always hated the cramped electronics compartment of my old Prusa. And finally, Also added a hole for the Wi-Fi antenna for perfect reception. Next came wiring, and for that it's basically the must to own a crimping tool. I also don't have a very expensive one, but it does its job very well. The board comes with a complete set of crimp terminals to add suitable plugs to the end of the existing wires, because the ones on the Prusa didn't always fit the new board. I won't go over all connections, but put a full description on my website if anyone wants to do the same, which is also a great segue to today's video sponsor, Squarespace. Their support tremendously helps me to create content on this channel and provides such an easy to use website creation tool to give you all this additional content to the videos. It doesn't matter if you're a content creator, tinkerer, artist, or a business owner. Squarespace is where you need to go if you're looking for a professionally looking website. Try out how easy it is to get started with a totally free trial at squarespace.com/cnckitchen. And when you later decide to launch your website, make sure to use code cnckitchen for 10% off, and so that they also know who sent you. Creating your own web presence is as easy as selecting one of their beautiful templates and then customizing it to your needs with your own content or using their vast selection of stock photos. Need an online shop? Squarespace got you covered. Do you have a question about a feature? Check out the great help or contact their 24/7 support. I'm seriously not chilling here and enjoy using Squarespace every time I create a new website article. If you think about creating a website and supporting the channel, check out squarespace.com/cnckitchen and use code cnckitchen for 10% off on checkout. Now let's get back to wiring. I snipped off the old plugs, stripped off a bit of insulation, placed the crimp connector onto the tool, inserted the wire and crimped everything together. It might be a bit tedious initially, but it's a very satisfying procedure as soon as you get a hold of it. I had to learn that placing the connector into the tool at first makes the work much easier. I also noticed that I had to painstakingly pay attention that the first crimp only squeezes the wire's insulation part and the second one must only wrap around the wire core itself. The power in and also the bed heater cables were connected to the board via proper cable lugs that should be able to handle the higher currents of the old 12-volt system. The hot end heater used a slightly bigger type of crimp connector than the rest of the system due to the current requirements. I reused some of the existing plugs that were already on the cables, since nothing will move around in the case, so I'm not worried about them not locking in place. The rest of the wires were all recrimped so that they matched the proper pin out on the Duet board. I was able to reattach all of the existing wires to keep all the old functionality, and all were long enough for the new mainboard, so no soldering was necessary. The only botch I had to do was for the Noctua fan, because that's running on 5 volts instead of the 12 volts input voltage. Fortunately, the Duet board switches the fans on the negative side, so I was able to hook the negative side to the normal fan pin and stole 5 volts from another unused connector. And that's it already. I have expected wiring to be way worse, but in the end, that didn't turn out to be as bad. Since I'm using the Wi-Fi version of the board, I had to add the SSID and the password by connecting the board via USB to my laptop and then sending the correct G-code command via Prontoface. I started with the configuration itself. I upgraded to the latest firmware, which is as simple as downloading a zip archive from the Duet GitHub, uploading that using the web interface and starting the update. When you're doing a completely new configuration where you don't have any reference data, similar to my Prusa Duet project, you can use the RepRap firmware configuration tool. This guides you through the whole setup process and with the help of the wiring diagram, lets you assign most things for your setup. In the end, it'll generate an archive with all of the necessary files required for the initial configuration. You again just upload them via the web interface, where they can also be further edited. Going through the configuration file might be initially overwhelming, but it's built up totally structured. You define the general settings, assign the drives to the axis, set up the axis and configure the limits. Heaters, sensors and fans get set up. Everything in simple G-code commands. Just open the G-code reference on the side and it's pretty easy to figure out what all of them mean if you need to change a parameter. I'm Frank here. I also checked other configuration files, for example the one for the Caribou Duet that helped me figure out the configuration for the Pinda probe with temperature compensation. And this is the great thing about RepRap firmware. Even if you're new, changing configuration is as simple as sending a G-code command without any firmware recompiling. I also linked my configuration below if you want to take a look at it. Additionally, just browsing through the Duet forum helped me a lot, and basically all of the questions that I had were already asked several times by others. Also something neat, the 5-stepper drivers for the Duet 3 Mini allow gantry leveling. The lead screw motors of the Z-axis are connected to individual drivers, so you can home the printer on the beginning and on the end of the X-axis and automatically remove the tilt. This should reduce the amount of mesh bed compensation you need to apply in the end. What might also be unusual for some are the other .g files that are on the SD card. And rather than having pre-configured procedures for homing, pausing, etc., RepRap firmware does have a separate G-code file for all of these procedures. The standard procedures usually get you starting, but if you specifically want to change order, speed or location, these are the files that you need to edit. As I said, overwhelming at first, and it also took me a bit of time to get used to it, but in the end, it provides you with an outstanding amount of customizability. Also, check what others have done in their setup. Adapt and learn. I guess you have noticed it already, but one, maybe for some, big downside of my mod is that I can't use the old 2004 LCD with the encoder anymore. So I now have a blunt nose Prusa. The board does support the slightly more advanced 1286-4 dot matrix LCD, but what you should really use are the touchscreen panel Duet. Since they cost almost as much as the board itself, I cheaped out just because the web interface works so well, and I also rarely miss the physical screen on my tool changer. But let me know, is not having a physical screen a no-go for you, or are you just as happy using the expensive screen that you anyway carry around with yourself all day? Maybe I'll add a touchscreen in the future, who knows? Tuning wise, I didn't really have to do a lot to get the same or even higher level of quality and reliability that I had before. I made a copy of the Mark III Prusa slicer profile and just adjusted the starting G-code a little. I added the Duet board's IP address to directly send the sliced model to the machine with one click. Quality is excellent that way. If you've watched my previous video, you'll know that I had Z-bending issues due to the bang bang heating, but fixed that by switching to PID control. During that endeavor, I also had problems with stutters and blobs that came from a too low PWM frequency. 25 Hz solved that. RepRap firmware uses pressure advance instead of linear advance, which does basically the same and also tries to compensate for over and under extrusion during speed changes. The calibration values are not the same, but I still use the handy Marlin K-factor calibration pattern and simply replace the M900K by M572 D0S using a text editor. So in the end, how happy am I with the Prusa Duet mod? Very! I still have a filament sensor, mesh bed leveling, full Prusa slicer support, the Noctua fan and even gain automatic gantry leveling. The silent stepper drivers make it way more pleasant in my office, and I even now have an integrated and snappy web interface. I might be adding a screen just for the sake of usability, but I haven't really missed that so far, even though it looks a bit weird in comparison. Let me know what's your control board of choice and if you'd consider the Duet 3 Mini for your next project. Is RepRap firmware something you're interested in? Thanks for watching everyone, I hope you're doing all well. If you found this video helpful, then leave a like, share it with the community and make sure that you're subscribed. If you want to support the channel, head over to Patreon, become a YouTube member or even check out my merch. Stay healthy, auf Wiedersehen and until next time.